Okay, now we're doing our video for notes. So let's get this started. I've already made a little bit for you. Okay, so today's topic is sort of tough. I'm going to go slow. When I go over these examples, I didn't try to give you that many on homework because I know they take a little bit of time. You are definitely going to need your calculator. Make sure you have your calculator ready to go. Okay, first one I'm going to start with, we already know how to do areas of rectangles and that kind of stuff. When you were earlier in the year, when you were in middle school, when you were in elementary school, your teacher taught you how to do area of rectangles, and we just did circles and squares, so you know some basics. Um, right, so any rectangle, length times width, area of a rectangle, okay? Um, Trapezoids, we learned earlier in the year, right? Trapezoids are where you only have one set of parallel lines, remember? Doesn't have to be symmetrical or anything. Um, but you have your trapezoid, and your trapezoid, remember, you have to add the two parallel lines, and then hopefully they tell you the height of the trapezoid, and your area would be the height times base 1 plus base 2 divided by 2. So that's your trapezoid formula, okay? Well, today we're going to learn two more formulas. We're going to learn for rhombuses and for kites because they have the same formula. So a rhombus, remember, is a parallelogram where all the sides are the same. I was doing this with my son the other day. We were going over quadrilaterals and he had to learn about them. So when all the sides are the same, right? Opposite sides are parallel, all the sides are the same, like a square that is leaning over. So that is your rhombus. Oh, come on. So on your rhombus, the one way to do the area of a rhombus is to know the diagonals. So if you know the length of the diagonals, like that one and that one. So if you know how far across they are, then your area, one way to do formula is diagonal 1 times diagonal 2 and divided by 2. If you can do that, where diagonal 1 would be one of them and then diagonal 2 is the other one. The whole thing, not half of it, the whole diagonal. And then a kite is the same basic formula. So a kite doesn't look like a rhombus because you do not have any parallel sides. But remember, a kite has two congruent sides that way, and then two congruent sides that way, right? So no parallel sides. These two are congruent. This one's the same length as this one, and this one's the same length as this one. So same thing on a kite. We really need to know the diagonals. So if you know the length of that diagonal, and then you know the length of that diagonal, the whole thing from one side to the other side, then your formula for a kite is also diagonal 1 times diagonal 2 divided by 2. So really you just need to know how long the diagonals are on a kite, and you can figure out the area of the kite. So these are two formulas we're going to use on the first homework problems before we get into our regular polygons. So here I gave you two examples. This one is a rhombus and this one is a kite. So to find the area of this rhombus, you'd have to remember about parallelograms. If this is 10 from here to here, then that would mean that that is also 10. If this is 6 from here to here, that would mean that is also 6. Because remember, in a rhombus, the diagonals are bisected. So the length of the longer one is 20. The length of the shorter one is 12. And then you would do 20 times 12 divided by 2. That's it. That's all you got to do. Just got to know the whole diagonals. And then you can do 20 times 12 divided by 2. So the area of this rhombus is 120 square units. They didn't give me my units, so I'm just going to put units. So there is your rhombus. You just have to know the whole diagonal. Don't do 10 times 6. That's not going to give you the whole thing. So make sure you do 20 times 12, not 10 times 6 when you do that one. So this one, they did not give you the pieces. Remember, in a kite, we do know that this piece is the same size as this piece, but that doesn't really help us with this. But they told us the whole thing's 15. So this could be diagonal 1. This could be diagonal 2. So really, to do the area of this kite, you would just need to do 27 times 15 and then divide by 2. That's it. You're probably going to forget this formula eventually someday, because how many kites do you really encounter out there in the real world? Not many. But this one would be 202.5 square units. So there is your area of your kite. So kite and rhombuses are done the same way. Multiply the diagonals, take them divided by 2. You wish that was it. You're like, yeah, that's it. That's easy stuff. But that's not it. That's just part of the homework. The next part gets a little bit more complicated. So we're going to start doing polygons. So let's get into polygons. Okay, now remember, polygons have many sides. It could be a hexagon. It could be an octagon. It could be, I don't even know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Could be a dodecagon. You just never know. It could have many sides, but we do polygons basically the same way. Now, yours are always going to be regular, which means, remember, all sides are congruent. We are not going to make you do complicated ones that you do not have matching sides. Okay, so we're going to do only regular ones. In order to do the area of a polygon, I can't really do the shape. There's different things. Some people will divide a hexagon into 2 trapezoids. Some people will divide it into rectangles and triangles. There's many ways to do these problems. I'm going to show you a method that will work for every polygon. Doesn't matter what kind it is. It will always work. So in order to do the method I'm going to show you, I need to probably enlarge these a little bit. So I'm going to make this one a little bit bigger. Make this one a little bit bigger. Make this one a little bit bigger. Okay, so here I'm showing you with 3 different ones how we do it. Okay, so here's the first thing. Find the area. Okay. First thing I need you to do is I need you to figure out this angle right here. So I need you to figure out that angle. So we have to do some thinking here. This is a regular polygon. If you drew in all of these lines, let me show you. If I draw in like here, to every corner, here, there, there, and there, you see we have divided the shape up into triangles. Okay, so the shape is all divided up into triangles. So we can divide it up into triangles. The cool thing about these triangles is they're all the same. So really, I'm just asking you to find the area of one of these triangles. So we are going to find the area of one of these triangles. And then once we find the area of that one triangle, then we multiply it by how many we have. On this shape, notice there's 1, 2, 3, 4, 5, 6. This shape has 6 triangles. Notice it had 1, 2, 3, 4, 5, 6 sides. So the number of sides tells you how many triangles there are. This one has 6 sides, so it has 6 triangles. When I go over to this one, and if I draw in all the triangles, okay, there's 1, there's 2, there's 3, 4, 5, 6, 7, and then 8. So notice there are 8 triangles in that one. And in this one, there will be 12 triangles if I drew them all in. So you do not need to draw all the triangles in. That's not the whole moral. You need to just have one. Okay, one triangle is all you need. Okay, so I need to figure out this angle right here. So here's how we figure out that angle. Well, we know if we go around the whole shape, that central angle would be 360 degrees. So if I divide the 360 by how many triangles I formed, this one was 6, I end up getting that one angle. So that tells us that each of these triangles has an angle of 60 degrees. 60 degrees in a hexagon. 60 degrees, right? If I go around, they're all 60 in a hexagon. Now, they drew in this height, because we really need to know a height to do an area of a triangle. So they drew in that height. So when they draw in that height, it takes the 60-degree angle and it cuts it in half. So you're going to divide the 60-degree angle in half, and that is the angle we are interested in. So that, right, that's just a battle to figure that out. And people are going to struggle. But that's the angle I need to figure out. Okay, so I'm going to give you a little chart because this chart will help you so you don't have to do it every single time. So I'm going to give you some of the common shapes that we encounter. You can always come up with these numbers again, or you can look at your chart. So I'm going to put the name of the polygon here. I'm going to put that angle for that little right triangle. So the polygon. So let's start with a, we just did a hexagon. So that's when you have 6 sides, right? And the angle in a hexagon is 30 degrees. And it's always going to be 30 degrees. That will not change. Okay. Another common one is, what about a pentagon? I didn't give you a pentagon as a problem here. But if I had given you a pentagon, it would have been 5 triangles. So the angle on a pentagon, 360 divided by 5, cut that in half, would be 36 degrees for a pentagon. Okay, we don't need to do anything less than a pentagon, because less than a pentagon, you're just a rectangle or a square or something like that. You don't have to do all this. So we usually don't do 7s. So octagon, the one I have second there. So that one is going to be 360 divided by 8. Cut that in half. That's going to be actually 22.5 degrees. So it's fairly small, and that's a decimal. Another one that's common is a decagon, right? 10 sides. Decagon is going to be 360 divided by 10. That's 36. Cut in half. That's going to be 18 degrees for a decagon. Okay, so these are some common ones. We'll figure out the dodecan when we get to this one. So we know the angle's 30. So this is what I'm visualizing in my head. I'm looking at this triangle right here. Oh, it's the same color. I'm going to pick a different color. Looking at this triangle right here. Okay. And you are going to find the area of this triangle. All right, it's a right triangle. So I'm going to zoom in because, right, that's really hard to see. So I'm going to zoom in on that triangle. Here is my zoom in on that triangle. Okay, so I zoomed in on that triangle. We know this is a 90 right here. They've already told you that that is 3. And we know this angle right here, we just figured out that this angle is 30. Okay, I need you to figure out this side over here. So, 2 ways you can figure out that side. You can use trig, or you can remember your 30, 60, 90, 45, 45, 90. Most people, I think, in my experience, have forgotten that. So I'm just gonna use trig, which is why we learn trig before we get into this stuff. So here we go, trig. I'm standing here, so that means this side, the one I want to get, is the opposite, and the 3 is the adjacent, which means I'm going to use tangent, right, of 30 degrees equals opposite over adjacent. And there is my equation. Cross multiply and solve. So you get x times 1 equals 3 times the tangent of 30 degrees. So we're going to go to our calculator and we're going to type in 3 tangent of 30 degrees. 3 tangent 30 degrees, just like we did way back in chapter 9. 1.73. Make sure your calculator is in degree mode when you're doing this. 1.73. So my answer for that little piece on the bottom there is about 1.73. So if that is 1.73 from there to there, then wouldn't it make sense that this little one is 1.73? So now we know the whole side. The whole side are 2 of those. So 3 tangent 30. Whoa, I'm in the wrong mode. 3 tangent 30. Okay, times 2, I get 3.46. So that length of the side of the triangle is 3.464. Okay, that is the length of the triangle. So remember, to find the area of a triangle, you do base times height. Base is 3.464 times the height of that triangle. The height of that triangle is the 3 that they gave you. There's the height. Divided by 2. So remember, any triangle is base times height divided by 2. We're using that formula when we do area of triangles. So 3.464 times 3 divided by 2. Your answer should be 5.196. Okay, don't round it yet. That's the area of this one triangle, this piece of the hexagon, the whole triangle right here that I'm outlining. So we just found the area of that triangle. If I go back to highlighter, I'll highlight the area. I just calculated this, right? All the way, this whole one triangle, we just calculated. There, that purple triangle. So how many of those purple triangles do we have? We have 6 of those triangles in this shape. So times it by 6, and you get the answer, 31.18. Ooh, that is the answer, 31.18. It's your area of that whole hexagon. It's tough, right? It's really tough. I don't give you a lot of these. These are really tough. You have to be able to remember the angle, do your trig, get that, double it usually, do base times height divided by 2, then don't forget to multiply by how many triangles you have. It's a long process. For those of you who get lost, that's a long process to get lost in. You have mainly like 1, 2, 3, there's like 3 or 4 parts here that you can get lost in. This is really hard. Even when we're here live, if we were been teaching this, this is not an easy unit. So this section is not easy, no matter if I were teaching it to you live or we're doing it on video. It's tough. You just have to do the best you can. So let's try the second one, okay? Let's see what we get. If you want, go ahead of me in the video, pause the video, see if you can do it, and then turn the video on and watch it and see if you get it right. So this is 14. So I need to figure out the height of the triangle. So I really need to figure out how tall these triangles are. Okay. So we know that's 9. Oh, why'd you do that? Okay, we know that's 90 right there. We know these are all 14, 14. Okay, this is a octagon. So the angle in this corner right here is 22.5. So I'm going to draw a little zoomed in picture of that triangle. So here is a zoomed in picture of that triangle. Okay, so zoomed in picture of the triangle. This is 14. We know this is 22.5 degrees right here. Okay, so we would like to figure out that. So using your trig, this is the opposite, this is the hypotenuse, so you should be using sine. So sine of 22.5 degrees equals the opposite over the hypotenuse. Cross multiply, put a 1 under there, cross multiply, x equals 14 times the sine of 22.5 degrees. So 14 times the sine of 22.5 degrees is 5.3. I'm not rounding it in my calculator. Let it stay in your calculator, don't round it. So that is the length from here to here. So that's this right here. Well, we need 2 of those because we want the whole length of that whole side. So times that by 2. And the whole length of the side is 10.715. So there is the whole length of the base of that triangle. So now that we're looking at this whole triangle right here, okay, and I'm going to find the area of this whole triangle. So I know the base. Oh, I haven't figured out the height yet. Hold on, undo the coloring I just did. Okay, so now we need to figure out the height. So I got the base. Let's figure out the height. So if you want, you can use trig again, or if you want, you can do Pythagorean Theorem. I'm going to do Pythagorean Theorem, okay? So here we go. I'm going to do h squared, right, plus 10.715 squared equals 14 squared. Remember, this is the hypotenuse over here. So subtract this one over to this side. So I'm doing Pythagorean Theorem, and we get h squared equals 14 squared minus that big ugly answer squared. We get 81.186. And then square root to get rid of the squared, square root. So the height of this octagon is 9.01. So now we know the height is 9.01. I should probably use red there so you don't get all confused. So the height is 9.01 and the base was 10.715. So the area of one triangle in this octagon is the base times the height divided by 2. That times the base divided by 2. So the area of one triangle inside of this octagon is 48.273. Area, that is one triangle. That is this triangle right here. This whole triangle, using your trig, you have just found the area of that triangle to be 48.273. Well, how many of those triangles do we have? We have 8 of those triangles. So times it by 8. Don't round it until the very end on your calculator. And you are left with 386.19 when I round it at the end. And I don't have any units, so units squared. 386.19 units squared. It's long. It's a really long process and it's hard. We're not going to do that last one. I'll just leave that one off. Don't worry about doing that one. We're not going to worry about that one. Okay. Those two are good. You can sort of see the process. Okay. So we always need the base. We always need the height. Oh, there's a special word for this height. They don't like people to get confused, so they have a name for this height. I need to tell you what the name is. This height right here is called the apothem. That is the height. Height of the triangle. We call that the apothem. Okay, so if you see the word the apothem when you're doing the homework, that just means the height. I love the problems in homework where they give you the height in there and they give you the side. If they give you this one and this one, you don't have a lot to do. You just do the base times the height divided by 2 and then times by how many you have. You can basically skip right to here if they give you the base and the height. So we don't have to use trig on every problem. It's just that the harder ones require you to use trig on them. Just depends on what they gave you. So I'm going to adjust the homework. I think the homework I originally assigned on your assignment sheet is probably a little bit too long. So I'm going to go in right now and I'm going to change it and put it on there on Clever. I'm going to shorten it up a little bit, and in Google Classroom you'll see what the shortened one is. So good luck. It's going to be a struggle. It's going to be tough. I know it. I'll post a video probably on Monday going over it. Just expect it to be tough, okay, guys? Expect it. It's very, very tough. It depends a lot on your trig. And if you still don't feel comfortable doing your trig from chapter 9, this can cause a lot of issues on this section. So do the best you can. Be slow, methodical, write stuff out. I know when you do it on Clever, you're just putting the answer in, but use some scratch paper, write stuff out. So when you look at my video and I go over it, you can look at your scratch paper that you made and see where you went wrong. Okay, because everyone's going to pretty much go wrong. Okay, not many people will be perfect on this the first time they ever do it. So just understand that it's normal for almost everybody to have issues when you go through this for the first time. Okay, guys, good luck. I'm going to adjust the homework. We'll see you later.